Hi there. In the third part of this GraphQL language features tutorial, we're going to be looking at fragments, which are a way to reuse fields. In the previous part of this tutorial, we just finished exploring aliases. So I'm picking up where I left off on part 2 of this tutorial. If you didn't watch that part of the tutorial, here I have a query with no operation name where I'm using aliases to distinguish between one product field and another product field with two different IDs. Now, what you might immediately notice about this is that it's somewhat redundant. I want the same information on both of these products, product 1 and product 2, but I've had to write title and description a couple of times. It would be nice if I could recycle those fields into a common definition so that I could reference that common definition and not have to type out title and description. Especially if I'm working at scale and I need to get these fields a number of different times, I don't want to have to update the fields that I want in multiple different places. I just want to define them once. Fragments to the rescue here allow us to do exactly that. And the fragment syntax looks like this. Just below the query here, I'm going to use the fragment keyword. I'm going to name the fragment, so I'll just call it title and description. And what I have to do is I have to specify on what type this fragment can apply. And the syntax for that is using the on keyword, and then I specify what type. So I know that when I issue a request for the product field, that returns me type product. If I didn't know that in graphical here, I can hover over that and it says indeed the type that I get back is product capital P. So I'm going to write product. It's actually going to autocomplete for me. I'm going to open curly braces. And I'm going to specify the fields just like I was getting fields on a product type. So I'll write title and description. Now up here, the way that I actually say I want to use this fragment in terms of the return fields is I'm going to use an ellipsis, so 3 dots. And then I'll reference the name of the fragment itself. So I'll say title and description, and I'll do that in both places. So now when I issue this query, I'm actually expecting to get exactly the same information back. So title description on alias product 1 and alias product 2. And indeed I do. So where this really shines at scale is if I wanted to add another field here. I'm going to browse the product documentation for another field. Let's say it was I needed the featured image, and I needed that featured image's ID, let's say. I only have to define it once. I don't have to go into each reference of each time I use it to do that. So I'm going to issue this query, and lo and behold, I get the IDs back of those. So this syntax, here we've defined the fragment using the fragment keyword and then substituting that fragment in for fields over here. But there's another way to use fragments called inline fragments. And these tend to be quite useful if the schema that you're working with implements either interfaces or unions. All that a union means in a schema is that a field can return more than one different type. Let's say in Shopify schema, there is a place where I wasn't just expecting product back, but maybe I could also get a collection back or a customer back. Interfaces are somewhat similar, and they're used in GraphQL schemas when multiple different types have the same fields on them. What we would say is that in Shopify's schema, there's an abstract type, that's what GraphQL calls it, called node. And there are many other types that implement the node interface. Just to show you what I'm talking about here, I'm going to flip to the Shopify documentation of the node type in the admin API here. So there's node, and it's defined as an interface. And the only fields that this interface actually uses is ID. But many different types actually implement node. Many different types of entities on Shopify need to have a ID associated with them. So this includes quite a lot of things, including things like orders, products, and customers, among other things. I'm going to flip to a different piece of the Shopify documentation just to show you where inline fragments are quite useful when working with interfaces. So I'm going to flip to the documentation of this mutation called tagsAdd. And I want you to notice a couple things about this interactive example of tagsAdd. tagsAdd is a mutation that, as the name suggests, allows you to add tags to a taggable object. And how does it do this? Well, it allows you to specify the ID of the entity to which you want to add these tags. But what it does is it returns a node when you have done this. Now the only field on node is ID. So what if you know that you're tagging a product and you want that product's details back beyond its ID when you have completed this operation? What I'm going to do here is just for ease of use, I'm going to copy and paste this example because it's a pretty good one. Kind of gets you everything that you need to get up and running. So I'm going to copy and paste this, flip back to my store, and completely remove this query. And the complement to this is that I'm also going to use these variables down here. And what I'm going to do is that ID is not going to work. I'm going to substitute in the ID of a product that I know I have on this particular test store. And let's say I want to tag this product on sale, as literally add this tag for whatever merchandising purposes or reporting purposes the rest of my applications have. I'm actually not going to run this query just yet. What I'm going to say is, okay, well, I get this node back, but I also want to know the complete list of tags that come back on this node. And I also want to know the title of the product. Now you'll notice something's off already because GraphQL is not auto-completing either tags or title for me. But let's say I naively wrote this in an application and I wanted to do this. It says, hey, field's title doesn't exist on node. Well, that's weird. I know that I have just tagged a product. I just happen to know that the ID that I've supplied is that of a product. And I know products have a title, and I know that there's a property on them called tags if I were to explore the schema. What's going on here? Well, the product type implements node. So what I need to say is, if a product type is the type that comes back, tell me about those specific fields on products. So I'm going to use the inline fragment on this syntax just to show you the difference here. Like regular fragments, I'm going to start with a dot, dot, dot. And the syntax here is going to look like this. I'm going to say on product, open curly braces. And then I'm just going to move these two fields into this inline fragment. It's almost like an anonymous fragment where I've just defined it on the fly right inside of the fields. Now when I issue this mutation for tagsAdd, I now get all the data that I expect back. So it's saying on this node, there's the ID. That ID belongs to the node interface. And then the title and tags that don't belong to the node interface, I've retrieved because I've used an inline fragment. Basically, again, to recap, this says, if the node returned is a product, also fetch these fields. Now, the tagsAdd mutation in this particular case can operate on any node. So if I were to say add tags to customer, and I don't know ahead of time when I use this mutation in my application if I'm going to get a product back or a customer back, and or I want different fields based on which of those comes back, I could define another inline fragment here to say on the customer type. And then maybe I'd want their email, and I could drill into their addresses, for example. And again, this syntax is called inline fragment. Very useful when the schema that you're working with uses either union or interface types as part of its schema. Thanks for joining me for part 3 of this GraphQL language features tutorial. In the next part, we're going to be looking at what does working with pagination look like with GraphQL.